Alright, in this segment we're going to learn about limiting and excess reactants. So limiting reactant is the reactant which is used up first. Used up first. Okay. It also makes the least amount of product. The excess reactant is what has something remaining, right? So we have remaining substance. Okay? So the limiting reactant is very important because it determines the amount of product we can make. So what happens is when this reactant gets all used up, the reaction stops and you can't make any more product. So that's why the limiting reactant determines the amount of product that's formed. So how do we determine the limiting reactant? Well, if it makes the least amount of product, the easiest way is to convert both of the reactants to the same product. So in this problem, we have how many grams of ammonia can be produced from the reaction of 40 grams of nitrogen with 75 grams of hydrogen. Well, first we need a balanced equation. So if we're reacting nitrogen and hydrogen, and it says they produce ammonia, NH3. Then we need it to be balanced, so we'll multiply by 2 here and 3 there. Okay? So now we have 40 grams of nitrogen. We're going to convert that to ammonia. So first I need to change grams to moles. So grams of nitrogen on the bottom, 1 mole of nitrogen on the top, and that would be 28.02. Then I can go to moles of ammonia. So moles of nitrogen to cancel will go on the bottom. Moles of ammonia will go on the top. And that ratio is going to be 2 to 1. Right? And since it asked me for grams of ammonia, I'm just going to go ahead and convert all the way to grams. So we could stop at moles and determine our limiting reactant. But since it already wants to know the mass, we'll just keep going. So and then we have grams of ammonia on top. We add those up, we find we get 17.03, I believe. 14.01 plus 3 times 1.008 gives us 17.034 grams of ammonia. Right? And so that would tell us that nitrogen will produce how much ammonia? So we multiply across the top. And we divide by what's on the bottom, and we get 48.6 grams of ammonia. So this much nitrogen will make this much ammonia. Now let's see how much hydrogen will make. We have 75 grams of hydrogen. What can we make? So we're going to change our mass of hydrogen to moles. So 1 mole of hydrogen has what mass? Right, 2.016. Alright. Then our moles of hydrogen will go on the bottom. The moles what we want, which is ammonia on the top. And so 2 to 3 this time. So moles of hydrogen would cancel. And then our last step will be the same here because it's the mass of ammonia. So again, we're going to multiply across the top and divide by what's on the bottom. So 75 times 2 times 17.034 divided by 2.016 divided by 3. And that gives us, let me make sure I did that right. I feel like I missed something. Okay, that gives us 422 grams of ammonia. Now, which of these are we actually going to make? Well, the least amount, right? Because once this much ammonia is made, the nitrogen's all used up. And so we cannot make 422 grams if nitrogen will only allow us to make 48.6. And so the limiting reactant here is your nitrogen, and the amount of product we can make is 48.6. So that means that the excess reactant is our hydrogen, because there would be some remaining. Well, how would we be able to determine how much remains of our hydrogen? Well, if we're going to make this much ammonia, we can take our amount of ammonia and we can convert it back to hydrogen. Right? So grams of ammonia will go on the bottom, moles of ammonia will go on the top, and we said that was 17.034. And our ratio of ammonia to hydrogen was 3 to 2. And then we convert our moles of hydrogen into grams of hydrogen. And this would tell us the amount of hydrogen that is used. Okay, this is the amount used of hydrogen. And so we multiply across the top, and we divide by what's on the bottom, and we get 8.52 grams of hydrogen would be used. Well, if we started though with 75 grams, how much remains? Well, we would just subtract. And we get 66.5 grams of hydrogen remaining. Now there is another way that you can solve this, and that is to convert excuse me, your 40 grams of nitrogen to hydrogen to determine how much would be required, again how much is used to react with 40 grams of nitrogen. You would get the same amount and then you would subtract. So you could either take the amount of product formed or the amount of the limiting reactant that you started with and convert to your excess to determine the amount of excess used, and then subtract them to find the amount that remains. Alright, so you do the practice problem, and then I'll come back in a moment and we'll look at it together. Okay, so in this problem I gave you the balance equation. It tells us we have 0.45 moles of MnO2 that are reacting with 48.2 grams of HCl. How many grams of chlorine could be produced? Right, and how many grams of the excess reactant remains? So we have two things we have to figure out. So we have our 0.45 moles of manganese 4 oxide, and we want to know the amount of chlorine. So let's convert to the grams of chlorine. So moles of MnO2 will go on the bottom, moles of chlorine will go on the top. In this instance, we can go straight to the mole ratio because we already know the number of moles. What is the mole ratio? Well, it's 1 to 1. And then we can convert our moles of chlorine to grams. So the molar mass of chlorine is 70.9. And then we multiply across the top and divide what's on the bottom. In this case, we get 32 grams of chlorine would be formed from MnO2. Well, how much can we get then from HCl? So 48.2 grams of HCl. The first thing I want to do is convert that into moles. So 1 mole of HCl has how many grams? Well, we have 35.45 for the chlorine and 1.008 for the hydrogen. That gives us 36.458 grams of HCl. Now that we have moles, we can use our mole ratio. So moles of HCl will go on bottom, and moles of chlorine will go on top. What is that mole ratio? Well, it's 1 to 4. And then finally, the last step will be the same as this one, converting that to grams of chlorine. Alright, so again, we multiply across the top and divide by what's on the bottom. And to three significant figures, we get 23.4 grams of chlorine. Alright, so again, which of these are the amount we're actually going to make? Excuse me. we're actually going to be able to make this amount, which makes HCl our limiting reactant, and our excess reactant is MnO2. Alright, so now how much of the excess reactant remains? Well, I ran out of room, so I'm going to use this scrap piece of paper here. I should have given y'all more room for that, I'm sorry. And so we're going to try the other method that I told you before. So we'll do 48.2 grams of HCl, and we're going to convert that to our excess reactant. So again, we convert our grams of HCl to moles. But this time, instead of going to our product, we're going to go to our other reactant. And so we have 4 moles of HCl to 1 mole of MnO2 here. Right? And since it was in moles, we're going to stop at moles. So we have 48.2 divided by 36.458 divided by 4. And we get that we would use 0.331 moles of MnO2 would be used. So how much remains? Well, we would subtract. So we have 0.45 moles to begin with, and we would subtract the number of moles that are used, and we would get 0.12 moles of MnO2 remaining. Okay?